Hello everyone! Here we are, we're going to talk about Algebra 1 today. And if you haven't already, hit that subscribe button if you like to learn about math. Alright, today we're going to be talking about transformations. And this is much easier than Laplace transformation, which y'all will study many years from now if you're doing Algebra 1 now. Potentially. And we're doing transformations on the coordinate plane. Now, we only have one goal, but there's a lot packed in this one goal. We're going to transform figures. Whoa, that sounds cool, right? We're going to transform figures on a coordinate plane by using reflections. Is that like when you look in the water and you see yourself? Translations. Is that like when you speak a different language and someone tells you what they're saying? Dilations? Is that like when you go to the optometrist and they dilate your eyes and your pupils get larger? And rotations. So, is that kind of like a rotato when you're doing cooking and you're peeling your potatoes? We'll find out here today. Alright, so let's start out with some definitions. Alright, the first one is transformation. We want to know how to be transformed. There's lots of kinds of transformations out there. And maybe you've seen the movie Transformers, where things look like something and then they look like something else. And that's really what we're doing here today. So this is movements. I like to move it. Of geometric figures. Okay. So we're going to be looking at things like triangles and circles and rectangles and parallelograms and all these fancy things, and we're going to be moving them. It's like when we're on the dance floor, we move. Alright, now let's look at another definition. Preimage. Preimage. Well, this is the position of the figure before the transformation. Alright, so if we were watching the movie Transformers, this is when the Transformers are vehicles. So this is before they are transformed. Alright, let's look at another definition here. Image. Everybody knows what this is. It's like when you look at a picture, right? Well, not so much in the mathematical world. So this is a position of the figure after. This was before, this is after the transformation. That's not after, it's after. What kind of word is that? After. Oh, we already wrote the word after. I'm mixing words here. After the transformation. Okay. Now, when we first talked about this, we said we're going to be transforming figures on a coordinate plane by using four things: reflections, translations, dilations, and rotations. So now we got to talk about what are those four definitions of reflections. Let's go here. Reflections, translations, dilations, and rotations. So what is a reflection? So this is kind of like looking in water and you see an image of yourself. So this is when we flip a figure over a line. So if you imagine if the surface of the water is the line, there's an image of you on the other side. Well, in this case it's actually on the water, but if there was a line halfway between you and the y, then that would be the line that you're flipping across. All right, translation. This is when you slide a figure in any direction. All right, so you keep it on the same plane. So if you draw on a sheet of paper, it's still on a sheet of paper, but somewhere else on the sheet of paper. You don't put it behind the sheet of paper or up in the air or something. That still stays on the sheet of paper. Okay, dilation. So is this like when your pupils get very large when they put those eye drops in at the optometrist? Sort of. This is the enlarging or reducing of a figure. So you make it larger or smaller, basically. All right, rotation. Man, we got a lot of definitions here today. A lot of words. I thought this was math. It is math. All right, this is the turning of a figure around a point. Okay, so let's say that you are pushing a chair in your living room and it got stuck on something and you're pushing it, but then it starts to lift up on your end. That is rotating about the corner there of the chair. That's about a point. So this is rotation. All right, let's look at some examples. Okay, example 1. And there's several parts to this. We want to reflect the triangle over the line. All right, so we have a triangle here drawn, and there is a line here. Okay, let's draw that line in a little bit different place. Okay, so what we want to do is we want to reflect this triangle over this line. So the part that's closest to the blue line still needs to be closest to the blue line on the right, and it needs to start and end at the same location. What I mean by the same location, this same point here. Okay, now we're going to draw the other parts. Okay, I know that doesn't look exactly the same, but it's supposed to. My artistic skills are not there. All right, let's look at part B. We are going to translate the circle to the right. All right, so we have the circle. And what we need to do is translate it to the right. Do you know your right and left? I sure hope so. So if we do it to the right, then it's over here, and it's the same circle. Imagine the circles are the same. All right, let's do another one. We are going to dilate the circle to be larger. Okay, so we have a circle here. And so what we need to do is we need to make it grow out, right? It needs to be larger. So then it looks like this. So same circle, just larger. Okay, let's keep going here. We have one more part of this example. We want to rotate the square 45 degrees clockwise. So if you ever see CW, that means clockwise. So that's the direction of the hands of the clock as it's telling time. CCW would be counterclockwise. Okay? So we have this square here. Okay? And what we're going to do is we're going to rotate it clockwise 45 degrees. Okay? Oh, look at that. We rotated there 45 degrees. Great job. Here we go. All right. So now we've done this, but we haven't done it on a coordinate plane. So that's our next goal. We have to build us a table now. Okay. So we're going to start out with name. We're going to describe this with words. And then we're going to describe it with symbols. And then we're going to look at the model. Whoa. I don't know what letter that is. Model. Okay. All right. Let's start with reflection. Okay. So to reflect a point over x axis, multiply the y coordinate by -1. Okay, and then also to reflect a point over the y-axis, multiply the x-coordinate by -1. Okay, so let's look at this. So x comma y coordinate becomes x comma minus y. So the y is multiplied by -1. Let's see what happens down here. So we got x comma y. This becomes minus x, positive y. So we multiply the x by -1. Alright, so let's draw this. X and y-axis. Okay? And let's say that this is x comma y. So it's 1, 2. Okay? Now we want to reflect it over the x-axis. So we would do x, leave it the same, so that'll be 1, and then the y will become -y, so it'll be -2. So this will be x minus y. Okay? Now, let's do minus x, y. So in this case, we would have minus x, let me draw a little bit better, minus x, y. So we still have the +2 for y, but instead of +1 for x, we have a -1 for x. So great job. Alright, let's talk about the next one. Let's do translation. Okay, so to translate a point by an ordered pair let's say A comma B, add A to, no, add A to X to the X coordinate, and B to the Y coordinate. Okay, so let's see how this looks. So we have X comma Y, and that becomes X plus A, Y plus B. So let's look and see how this looks. Okay, so let's say that we have X and Y here. Now we don't know what A and B are, so they can be anywhere. So when we add A to X and B to Y, it just changes where it's at. It could be over here, it could be over here, it could be over here, we don't know. So this would be like for X and X plus A and Y plus B, if we chose this point here, after we've added A to X and B to Y, and it ends up landing there. Okay, so let's keep going here with this table. Alright, now we have dilation. So to dilate a figure by a scale factor, let's use K, multiply coordinates by K. Okay, so let's look how this looks here. So if we have X comma Y, this becomes KX, KY. Interesting. Okay, let's put this on the model. Model time. Alright. So let's say that X comma Y is here. So then we multiply by K, it becomes this up here. Let's say that's positive K. Okay. So in this case, K would be bigger than 1 because it's getting farther from the origin. If it's getting closer to the origin, then K would be between 0 and 1. And if K was 0, then we would be on the origin. Alright, let's look at another one. And this is rotation. So rotation. So to rotate, not rotate, rotate. To rotate a figure 90 degrees counterclockwise about the origin. Switch. Oh, got a couple letters backwards there. Switch the coordinates of each point and then multiply. Then multiply the new first coordinate by -1. Okay, now let's talk about a part 2 to this. We could rotate a figure 180 degrees. Whoa. About the origin. So then we multiply both coordinates of each point by -1. Okay? So let's look and see what this looks like. Alright, so if we have x comma y, that becomes minus yx. Whoa! So your y becomes a minus y, but that's in the x place, and x just moves over to where y was. Interesting. Alright. Now let's look and see what we get here. We get x comma y, that becomes minus x minus y. So you don't swap either one of them, but you multiply both of them by -1. This is kind of cool. So let's see what these look like. I feel like my horizontal lines are much straighter than my vertical lines. Alright. Let's say that we start at 1, 2. And this is x comma y. Alright, so then, let me draw that in white, actually, to not confuse us. X comma y. Alright, so then x, what we're going to do is we're going to rotate 90 degrees counterclockwise about the origin. Okay, so then x just moves over to the y, and then y gets the sign swapped and moves over to the x position. Alright, so then if we're rotating here, we get to this point. So this is like minus yx. Okay, now let's do the rotate about 100 degrees about the origin. So then we end up down here because we're minus x and minus y. So positive 1 becomes negative 1. Positive 2 becomes negative 2. Alright. So great job. So let's look at an example here. Example 2. Triangle ABC 1, 2, 3. Alright. Has vertices. A is 1, 4. B is 4, 2. And C is -1, 2. Alright, we have multiple parts to this. We have A. We want to find its coordinates after it is rotated 90 degrees counterclockwise about the origin. Okay, that's part A. Then part B, we want to graph the preimage, not per image, preimage and image. Okay, so let's look at part A. So if we recall, when we have x comma y, this becomes minus yx. Okay, so we had A 1, 4, we had B 4, 2, and we have C -1, 2. Okay, So we got to translate this. So this becomes minus 4, 1. And this is minus 2, 4. And this is minus 2, minus 1. We did it. That's part A. This is part A of the problem. Great job. Now all we have is part B. Part B. We got to graph the preimage and the image. Okay. Man, those are really squirrely vertical line. X-axis, y-axis. All right. So let's find point A. And we're going to draw... Oh, I meant to mention that this is A prime, B prime, and C prime. Okay. So in red, what we're going to do is draw the preimage. And then in white, we will draw the image. Okay. So let's do red first. So 1, 4. So 1, 4. There's A. All right. 4, 2. 1, 2, 3, 4, 2. There's B. And, well, let's put that B a little bit down here. Okay. And then C is minus 1, 2. Okay. There's C. Alright, so let's connect these to make a triangle, because that's what we're drawing, right? It's a triangle. Okay, so we have rotated this 90 degrees, right? Counterclockwise about the origin. So we're going to end up in a new location, and we're going to draw that in white. Okay, so then we end up with negative 4, 1. Okay, here's A. Prime. All right, B is negative 2, 4. Here's B prime. Well, let's move this C over. It's going to get in the way. It's over here. Okay. And now C prime is negative 2, negative 1. C prime. All right, let's draw lines in between, line segments in between each of these endpoints. All right, so we did part B. This is what it looks like when it's rotated counterclockwise 90 degrees about the origin. Great job. This has been MultiPro. Please subscribe if you haven't already. See you all next time.